Hello, my name is Mikhail Minin and I am from University Bremen, and today I will show you how to use the plugins we have developed for interfacing QGIS with VESPA Virtual Observatory and how to access data available through our server. In front of me is a 32-bit Ubuntu virtual machine, so I am just going to log in here and access GitHub page for our tutorial. In this tutorial, you will learn how to install plugins we have developed, how to browse WMS layers exposed on our server, how to load them as a base map in QGIS, how to run complex geospatial queries using ADQL on DSHS, and how to load it to QGIS using our plugin, how to load previews of crease and coverages onto the map, to access spectra of individual pixels on crease and coverages of interest, and broadcast this data to VO, virtual observatories, spectroscopy applications such as GIS. For all of this, we will use data available through our dedicated server on epn1.epn-vespa.jakobsuniversity.de. So now in front of me I have this tutorial, and we shall begin through the installation of the necessary plugins. First, open the GitHub release download link and copy the plugins over to the QGIS plugins directory. So now we can start QGIS, and the plugins should be already visible. If not, then go to Manage and Install Plugins and check your plugins, and there you should see it. The next step would be to import WMS base map to our QGIS. So first we should open our EPN1 server, go to Tab and then Tab Handle. Tab Handle is a user-friendly web-based interface that allows you to view and query the DSHS tables available through Virtual Observatory. Here I am going to open the USGS WMS astrogeology map schema, the table EPN core. As you can see, this is an EPN tab compliant table. In our table, preview URL field provides a link to a very simple open layers WMS where you can browse through the USGS astrogeology maps. Here you can find maps of many different planets and satellites in our solar system. Since I only want the maps of Mars, I will select where target name equals to Mars. Click Submit. Now click on Preview URL. This looks like a nice base map for Mars, so we are going to use this. Click on Access URL Data Preview, and it opens you this Get Capabilities WMS page, which tells you more about the service. This is what you want to provide QGIS in order to access the map. So just copy the URL, switch back to the QGIS, and here click on Add WMS Layer. Say New, give it a name, add the URL, click OK, and connect. So here I will just select the first one, and now you can see that the map has successfully loaded into the QGIS. Now we can switch back to our tutorial and proceed to the next step. At this point, we are ready to add some vector data to our project. For this, we need to start some hub and QGIS some client, and then send information from web client to the QGIS client via SAM. QGIS then takes care of requesting data from the DSHS server and writing it to the hard drive. SAMP is simple application messaging protocol which enables interoperability of virtual observatory tools. To better explain the data flow process, I have prepared this diagram. So at first, we have a user who initializes SAMP hub and QGIS SAMP client via QGIS graphical interface. The user then interacts with the database through one of the DSHS clients, which are any of the virtual observatory tools meant for data mining, such as TopCat, or form-based DQL, which we will be using later, or TabHandle, which we just used. These tools provide querying and data discovery services. User can then request the DSHS client to transmit the table via SAMP. This sends out a message to SAMP hub, which is then picked up from the hub by QGIS SAMP client. QGIS can then request the data from DSHS database and save it somewhere on the hard drive. Our plugin requests data from DSHS as VO table, saves it as a GeoJSON, and then converts it to SpatialLite, because SpatialLite format is somewhat easier to work with in QGIS. So we begin by formulating an ADQL query for the DSHS. Here I am selecting crism coverages that intersect Mars craters with a diameter between 50 and 80 kilometers. Copy and paste this URL into your browser's address bar. This opens an HTML page for form-based ADQL. You can find ADQL query on the bottom and modify it if you want. To send this via ADQL, you just click on this button. Now it says that there is no SAMP hub running, meaning that we need to go back to QGIS and start the SAMP hub. To stop the hub, you just need to close this window. Also start QGIS SAMP client and click connect. It tells me it's waiting, so I switch back to the ADQL page and send this table via SAMP again. Now you will see a window asking for consent. Click yes. Send the table again and it is now loading the VO table from this URL. Now it wrote it to GeoJSON and converted it to SpatialLite. The result now appears in the table of contents. I just need to move it up and zoom in a little bit. And these are my coverages. I can make them more visible by changing the symbology. For instance, saying I want a wider border. And as you can see, they all overlay craters. Now, let us proceed to the next part of this tutorial. Close SAMP client by pressing disconnect and saying OK. Let us find a crater which we would like to explore. So suppose I am interested in an area near Niri Fossile, and I will just zoom in on this. And I can see quite a few craters in this region. So let's take a look at this one. So first I want to know the properties of this coverage. Now by clicking on this, I can see all properties listed in the tables produced by the table join from the Java database. Seeing in this form, I can tell you the crater morphology, the coverage name, and this crater doesn't seem to have a name. But let's see what the coverage actually looks like. So I select this using select feature tool, and now I can use Java image plugin, this one, in order to pull the crism image preview and to georeference this on the map. And now it asks me to provide a CRS, so I simply agree to what it says, and now I see my coverage preview plotted here. And now we are ready to proceed to the fourth and final part of this tutorial. Here we shall examine spectra at a point by using spectra extractor web-based interface and send it via SAM to a dedicated virtual observatory application such as GIS. GIS is an interactive spectrum analyzer. You can find more about it online. It is gis.irap.omp.eu. Begin by activating the layer containing the DCHS result and using the Identify tool to gain access to this feature's property list. Find the attribute subgranule URL, then copy and paste its value into your browser's address bar. This will open the Spectra Extractor tool, where you can click on any point on the coverage and the spectra will appear in this little window. Now you can start GIS. Once you have GIS running, switch back to the Spectra Extractor and click on Broadcast via Sound. It will ask you if you authorize the connection. Click Yes. And then click on Display Spectrum. Change the bottom axis to wavelengths and unit to micrometers. You will now see a spectral plot displayed in GIS.